Oi, look out! He's got a battery pack. That's not a battery pack. No, that's a battery pack. So, upon receiving feedback from my first couple of customers, I realised all the mistakes I'd made in the first version of this pack, mostly to do with the lid. So this is the new version of the pack. I replaced the cables and connectors with M8 bolts. I originally went with the pre-attached cable design for cost effectiveness, but this is only marginally more expensive and makes the pack more universal, as now all our connectors are just 8mm ring lugs. I had these funny wing nuts when I was prototyping this design, but they are a bit dangerous as you could short this easily by dropping any metal on the top of the packs. So the final design just has these bolts with covers on. They don't look quite as good as the wing nuts, but they're far more practical. I plan to handle all the assembly myself, but as per usual, I'll show you how the whole thing goes together. So I start by taking the fuse holder and inserting the two spade connectors into it. One of them has a chunk cut out so that it meets with the bolt nicely. And then they get bent over at right angles and clipped into the side of the lid here. Then the bolts get inserted into the hexagonal holes in the lid, and I get a plastic ring. If you look, it's got a little flange on the bottom, and one of these half nuts, and screw those on. I'm currently just using a bit of folded up nickel for the negative side. It works a bit better with the new bus bar. And I've got this plastic spanner which I can use to tighten these up without damaging the rings. It's cheap, so I can include one with every order, in case you ever need to break down a pack. Finally, we can put the covers on the bolts and screw those on. And that's it. Here's our 50A fuse. I also got these tiny ring lugs which were just 5p each, and they're too small for your main connections, but perfect for your balance leads. Another thing you may have noticed is the lid now sits flush with the sleeve, an obvious improvement, and that brings us onto the new bus bar. It's not as good looking as the previous stitched design, but it's more robust and much easier to attach. I made it by joining nickel strip with copper flat bar, which I can buy for just £1.50 a metre. And you're probably wondering where you can buy copper bar like this for such a low price. I'll tell you in a mo, but you probably also noticed that the nickel strips are joined to the copper bar in a weird way. If you look, they actually pass straight through the middle of it. Can you figure out how I did it? I'll tell you in a sec, but I also wanted to mention that this nickel strip is just as fusey as the copper wire, which I discovered earlier when assembling a pack and inserted the battery the wrong way round. The design's so hot, even I burnt my finger. So it's actually made from copper brake pipe from motorcycles. I use a jig to drill holes every 2 centimeters, and then insert the nickel strips using these simple spacers and flatten the whole thing. I'm just using this old vise at the moment, which doesn't even have a handle. But I'm getting a more appropriate tool called a bead roller. And to protect the copper, I'm now using this rust and slacker out of a nail varnish bottle. It's easier than dealing with dielectric grease. And I engaged in some branding, probably about 100 years out of date with the style here, but it is the 20s, what else am I gonna do? Also, the PLA material I was using for the first version turned out to be a bit more fragile than expected, so I switched to PETG, which comes out a bit wobbly. But a wobbly sleeve is better than a cracked sleeve. And it kinda gets smoothed out anyway when you insert your batteries, so I'm gonna go with it. Okay, so this is what a full set looks like. The cells, the inverter, and obviously the light bulb aren't included. Just empty packs, the battery manager, and yeah, after talking to my first customers, I changed my mind about offering breakers. Speaking of my first customers, I've taken care of them and sent them surprise Christmas presents. It's just a one-off and future customers cannot expect free updates. So I've got the BMS plugged in on the negative side here. The wires are hidden behind the back if you look. And yeah, I've got the ugly breaker plugged in on the right here. They managed to make it even more ugly by printing the rating on it in snot green. But I've got these nice DIN rail breakers. This is the 125 amp version, and yeah, it looks like it belongs with this with the red plastic and that you can see inside it all the little mechanisms that get triggered in undesirable circumstances. And yeah, there's a nicer looking marine breaker that also has a high amp rating. Now I'm not going to give you all the little interconnects at the top here. I'm just going to include a load of cable, 1 meter of each, and like 25 of these ring lugs, along with a cable cutting guide. And you don't need me to demonstrate this, but here's a tip. If you got a pair of pliers like this, with a flat bit behind the hinge, they do quite a good job. You can't pull the wire out. It's a totally legit way of crimping. I even use them for the small ring lugs. Even though I've got a dedicated tool for it, it just seems to smash the plastic. I could be using them wrong, but the pliers are good. So yeah, that's pretty much it. You get this bag of bits and bobs, there's at least one spare of everything. And if you look carefully, you'll see that there's some nuts and bolts in there. That's so that you can make up these little combining points, in case you want to put multiple sets in parallel. And that's about it for the update. We're still a ways off from professional manufacturing, but I'm confident enough in it now to do some decent volume. So look for a link in the description.